Hey everyone, welcome back to the Django QuerySets API series. Today we are taking an in-depth look at conditional expressions. If you have been sticking to basic filters and want to boost your query's flexibility and performance, this video is for you. Let's get started. Let's start with a basic example where we want to categorize our books based on certain condition. Handling this purely with Python, if-else statements can get inefficient and messy, especially when dealing with large datasets. This is exactly where Django's case and when expressions can make a big difference, allowing us to streamline the logic and improve performance. This is an example how previous if-else code sample can be overridden within Django conditional expressions, and as you can see here, each when block matches condition in Python example. Worth to mention that this will be mostly used during annotations, aggregations, filters, lookups, and updates. From the docs, a case expression is like if-else statement in Python. Each condition in the provided when object is evaluated in order until evaluates to the truthful value. The result expression from the matching when object is returned. Sounds good, isn't it? Let's review in details now. To construct conditional expressions, you need to use this pattern. To begin with, we need to import them from DjangoDB models. Then start with initializing case. It acts like a container for all conditional expressions similar to a switch, or as docs says, series of if-else conditions. Then you should have an one or couple of when objects. Each when clause represents a condition. It accepts keyword arguments representing the condition and specifies what value to return if the condition is true. Next bit is default argument. The default argument in case is similar to the else clause. If none of when conditions are met, it returns a value specified here. And closing one is output field. It's optional and used together with annotate. This argument defines the data type of the annotated field, chart field in this case. These expressions allow us to add conditional logic directly to our queries, making them incredibly powerful. For example, we can dynamically set fields based on a criteria right within the database query. This is especially useful when we need results that vary based on different conditions. Here's a simple example with our book model. Let's say we want to categorize book as affordable if they priced below $20 and premium if they above that. In this code, we use case to define two when conditions, one for affordable books and one for premium. Let's run it and visualize output after categorization. Price category field is created on the fly for each book instance in our query set, and we can see that it's correctly applied. Also, in this example, you might have noticed the new utility class from DjangoDB models, its value. Use it to represent a constant value in database expressions, extremely useful in annotations, aggregations, and conditional expressions. It accepts a value itself and extra argument output field. Also worth to mention that in when block you can construct complex query conditions using F and Q expressions from previous video. For example, like this. And then, after execution, instead of affordable, we will output a title of the book, and we're also going to include books with price equals none. Now let's talk about performance. By handling conditions directly in the database, we avoid fetching unnecessary data and doing the processing in Python, which can be much slower, especially with larger datasets. In this example, we will compare two approaches, one that performs conditional checks in the database using case, and another one that applies Python logic after fetching all records. Let's run them together and compare the results. As we can see, approach 1 reduces memory usage and speeds up execution, since the categorization happens in database. This difference becomes even more noticeable as our database size grows. Let's move to the next important bit related to the conditional expressions. Sometimes we need additional values or complex expressions in our conditions. Value let us set static values, while expression wrapper is great for more complex calculations. If you are working with calculated fields that rely on different data types, expression wrapper helps ensure the database handles everything correctly. Here's an example where we calculate discounted prices on a fly for books that are on sale. Here, expression wrapper let us apply a discount formula directly in the database. Books over $30 get 20% discount, and we only have to retrieve a single query set to see both the original and discounted prices. Let's take it a step further and explore how exactly to use conditional expressions during such kind of operations as filter, annotate, aggregate, and update. Starting with conditional expressions in filter. Let's say you may want to apply conditional filter on one field based on another field. For example, here we have filter by publish date based on author name. We want to get all books that were published less than a month ago from author A and everything published earlier than a year from author B. For any other author, we will just set some not realistic date. Before we run it, let's update our database and set all books published date to be 40 days ago. By doing this, we will trigger first find condition. As you can see in the response, we received only books from author A. And when we're gonna set published date for more than a year ago and run the code again, you may see that author B is also included there. Next is conditional expressions in annotate. You can annotate a book with custom fields based on a condition. For example, you can annotate whether a book is expensive if it's priced over $30. Otherwise, label it as affordable. The same example we did previously. After running this, you may see that books were properly categorized. Another interesting bit is when you want to get count of books that are considered expensive, over $30, and those that are affordable, using aggregate with conditional expressions. Conditional expressions together with count will do this job for us. When we run this code, we will get the result, which we can confirm by running next command in Django debugger. This one shows that there is really 6011 expensive books. And this one shows that there are 7,229 affordable books. Next bit is conditional expressions in update. If you want to update the price of books based on certain condition, you can use f along with case statement. For example, let's say you want to increase the price of all books authored by an author A by 10%. After running this code, you might notice that average price for this author is increased by 10%, as we expected. And last example here will be case in complex queries. Let's say you want to annotate each book with its age, how many years ago it was published. Then, for books published more than 5 years ago, you want to add a special label saying old, otherwise new. We are going to set publish date of all books to today, and then all of them should be marked as new. And when we set it to more than 5 years ago, it will be shown as old. Now that we have seen how powerful conditional expressions can be, it's time to see what's happening under the hood. Every case and when expressions is translated into SQL, case-when syntax, making it optimized for the database engine. Let's take a look at one SQL generated from our earliest example. As you can see, Django translates the case and when logic directly into SQL, case when statement. This means the database is doing the heavy lifting of categorizing the books, and it's all done in a single query. No need for custom Python logic to process the data after retrieval. So, with just a few lines of Django code, you can create a powerful conditional logic that runs directly in the database, making your queries more efficient and saving your time and resources. While conditional expressions in Django ORM can greatly optimize query efficiency, be mindful of situations where the logic might be too complex to implement cleanly with ORM alone. If handling conditions directly in Django ORM starts to become convoluted, especially with smaller datasets, it might be simpler and more readable to perform the logic in Python. Always weigh the complexity of your logic and dataset size to strike the right balance between ORM efficiency and code clarity. I would say here same thing about conditional expressions in Django ORM that Luciano Ramalho said about list comprehension in Fluent Python. Of course, it's possible to abuse list comprehensions to write truly incomprehensible code. If the list comprehension spans more than 2 lines, it's probably best to break it apart, or rewrite it as a plain old for loop. The only difference here, you can have more than 2 lines in conditional expressions. And that's a wrap for today's video. Remember, these features aren't just about cleaner code, they can dramatically boost your Django application's performance. If you enjoyed these pro tips, please like and subscribe for more advanced Django content. Leave a comment below if there is feature or technique you'd like to cover in the next video. Thanks for watching, and I'll see you in the next one.